This video is on section 5.2 from the Blitzer Precalculus textbook on the sum and difference formulas and using those with trig functions. Oops, I hit the wrong thing. I want to make that a little bit larger there. Let's focus it. Good. Now we've got some room to work with. And what we're going to do here is to use these particular formulas, the sum and difference formulas. Let me find one of the paper handouts and point it out. Here it is. So it shows it in the textbook and it also shows it here on this handout, the sum and difference formulas. This one's a little misleading though because there's the pluses and minuses, so they save some space, but they didn't identify that there's some differences here. So like when the sign here is plus, then this is a plus, and when this is minus, this is minus. But for the cosine, it's different. When the cosine is positive, when it's alpha plus beta, then the formula is negative in the middle, not positive. And when this part, when your two angles are subtracting, when it's alpha minus beta, then this one's positive, which is really weird. I guess you could say cosine's weird. Sine's normal and cosine's weird. And that might be one way to remember it. In tangent, if this is positive, the top is positive and the bottom is negative. And if this is negative, the top is negative also and the bottom is positive. So there's sort of some consistency there. One's positive, one's negative, and the top one matches the alpha plus or minus beta, whichever it is. So that makes some sense. The textbook shows them separately. This one doesn't, but at least you do see now, or need to know that. So make sure you remember that difference. That's an important thing to remember, otherwise you'll end up with the wrong, like, negative somewhere. So we're going to do a couple of problems to show you what to do with the sum and difference formula. So the first thing is I will remind you what I just said about pay attention to the plus or minus. Sine and tangent are consistent, I guess that's my way of thinking of it, is it makes sense. Makes sense. Cosine, like opposites. Opposite, which I'll say is simply weird. So whatever you want to do to remind yourself, just pay attention to that and make sure that you know that difference in the formulas. So now let's take an angle, cosine 345 degrees, and our direction is to find the exact value. So if you put it in the calculator, you're going to get a decimal. That's not the exact value. It's going to be a non-repeating, non-terminating decimal, and that means it doesn't have an exact value. You have to give the exact value, which means using a square root, like a square root of 6, a square root of 10. That'll be part of the answer, or something like that in it. So let me find, let's see, where do we go with this problem? Okay, I need a unit circle, because I want to point out something to you. Take a look here on the unit circle and find the find 345 degrees so that we can see the cosine. Uh-oh, we've got a problem. There's no 345 degrees. It's right in the middle here between 330 and 360, but it's not there. And that's because it's not one of the normal 30, 45, 60 degree or quadrantal angle ones. Since it's not one of those, we have to make it up from those others. We don't have to, there's probably other ways to do it, but this is a good way to do it because if you rewrite 345 degrees in terms of other angles that are on the unit circle, then you can use these sine and cosine amounts and plug them in and add and subtract or multiply, whatever you have to do, and get an exact value. So when you look at 345, what we want to do is we want to rewrite it as two angles. And we can do plus or minus. We're going to do this one as plus. So you think, what are two numbers that could add up to it? Well, one possibility would be 330 plus 15. That would add up to it. And here's 330, except that we don't have a 15-degree one, so we don't know the sine and cosine for that. So 315 degrees plus 30, that could work. So we have 315 plus 30, that's 345. Or we could do 300 plus 45. So there's a couple of ones to do. I'm going to take that one. I'm going to do 300 degrees plus 45 degrees. I could have done 45 plus 300. I would get the same thing. It really doesn't matter since it's plus here. So this one is the first one I put in, so that's the alpha, and this one's the beta. I'm going to use similar to the textbook symbols, the Greek versions of those. And I'm going to make a little note here that you're allowed to use other numbers, or other angles, I should say, to use other angles. Just for your sake, just make sure they are unit circle angles so that you can use the exact values. So that you can use their exact values. So that's a little like, hey, this is really important. This one's really important. You can use any combination, but it's really hard to do if you don't use ones that are on the unit circle. So there's a plus for you to remember that. And that's another reason why the unit circle is useful. So the formula for cosine alpha plus beta, let's find it here. It's cosine alpha beta and plus, so it'll be cosine alpha times cosine beta minus sine alpha sine beta. And in the textbook they show this too. So let me show you that. The page that it's on, they have these at the bottom of 558. And here they've written them out separately. So here's the plus for cosine, and it's minus here. And here's the minus for cosines, plus there. And for sine, plus and minus, it's the same, plus and minus. Tangents on another page. I'm going to look at that one later. So now let's go ahead and write the formula and then write the numbers. So I'm going to write the formula. Oops, this is supposed to be cosine. And here's where I put my b. And because that's adding, this one will be minus. And that will be sine and sine. And now we can simply put in, well, actually, before I put in the exact values, I'm going to put in these to sort of keep me straight on it. Cosine 45 minus sine 300 and sine 45. And now underneath it, I can actually write the separate ones. So if you go to 300 degrees on the unit circle, you see that the cosine is 1/2, and at 45 degrees, it's the square root of 2 over 2. And then we'll subtract, well, the sine at 300 is negative root 3 over 2, and the sine at 45 is root 2 over 2. And now it's just multiplying things. 1 times root 2 is root 2, and 2 times 2 is 4. Minus and minus makes that a plus. So we get square root of 3 times square root of 2, that's square root of 6, and 2 times 2 is 4. And we have the same denominator, so we can do square root of 2 plus square root of 6 over 4. We can't multiply those because it's adding. And we can't add them because that's actually 1 point something, and that's actually 2 point something. So we'd have to change them to decimals, and then it would not be an exact answer anymore. So we can say that the cosine of 345 degrees is equal to that. That's how you do it. You look at the number, figure out how to use 2 angles from the unit circle, put them into the formula correctly, put in the exact values, and then do the basic math with those exact values. Now let's do a second one of these examples. We'll call this one A. And so this will be 2, and this will be B. And this one is the sine of negative 105 degrees. And so it's find the exact value of that. So I'm going to do this problem, but if you're watching this, go ahead and do it yourself. And then try to do a step or a few steps. If you get stuck, then look and see what I'm doing and then stop the video so you can do some more on your own and keep on going. But first, go ahead and try to figure out some numbers that would add up to or subtract to make negative 105. And therein is a little bit of a difference. You're adding a negative, so you're going to need a smaller number, take away a larger number to get that. So play with that for a moment and see what you can get. Okay, now if you started the video again, you may have come up with a couple of numbers. For instance, you could have come up with 135 minus 30. Okay, and 135 is one of the ones on the unit circle, and 30 is, but when you subtract it, you get 105 degrees. But it's not negative, so you can't use that. But you could switch it around and do 30 take away 135, and that would give you negative 105. So that's one you could do. You could even do another one. In fact, let's look at this one, 45 minus 150. That would give you negative 105 degrees as well. So here's two possibilities, and there's probably others. And that's one of the things to know, is that there are different possibilities. You can have 5 people do this and do it in 5 different ways and all 5 of them get the correct answer. So as long as you have figure out how to do it and you're comfortable with the method, and come up with a way or come up with numbers that work to get the right answer, then you're correct. So you don't have to stress over getting the same one that I do or the textbook does if you get the right answer. Most of the time, though, the one we give will be pretty good. So I can use either of these. I'll use the 45 one. So that means I'm going to rewrite that as the sine of 45 degrees take away 150 degrees. So these are the same thing, but by doing this, I am now able to use the formula. This is alpha minus beta, so I have sine of alpha minus beta. So let's use the sine difference formula where it's negative, and that's going to be sine alpha cosine beta minus cosine alpha times sine beta. Now that's another difference with the formula. If you notice over here, when they did it with cosine, it was cosine and then sine and sine. But with the sine, it's not. It's sine, then cosine. And then it switches to cosine and sine. So there's something that makes sense to that, I think. You do sine, then you do cosine. And you can't just reuse sine of alpha again. So what you need to do is it has to be cosine alpha sooner or later. So over here you switch them. And it makes sense that the second one switched and the first one's not. Personally, it does to me. If it doesn't to you, well, just use this, pay attention to it closely. Now we can write it with sine alpha was 45, and beta, that means that's 150. Cosine of 45 and the sine of 150. Now, use the unit circle, and at this point, you can, if you're doing this and watching this video, you can stop at each point and see if you can do the next step yourself. The next one would be to put in the unit circle amounts for those. Go ahead and do that. And now if you're back, you can see that that one's square root of 2 over 2. That one you should have come up with negative root 3 over 2 minus root 2 over 2 and 1/2. Okay. Now you can multiply these out, and we get the 2 and 3 and a negative, so it's going to be a negative root 6, and that's over 4. Subtract, and that's going to be a root 2, and 2 times 2 is a 4. So we can put those together. What we would have is negative root 6 minus root 2 over 4. And actually, now I need to talk about showing the answer, because that's the answer here. We now have that sine of negative 105 degrees is equal to this. And you can write that, though, in a couple of ways, because we have both of these being a negative. That's an acceptable answer. You can do that. You can also take out a negative common factor, because you can do negative 1, and then that's root 6 plus root 2, and all of that over 4, or that negative can be in front. So that you could write this as well as and write it in this way, where it would be negative root 6 plus root 2 over 4. And so this is an acceptable answer, and this is an acceptable answer. Both of these would be equally acceptable. If you do take the negative out, you have to make sure you're careful with the sign, because then this one will become positive. Because you're taking a negative one, because this is connected together as if this whole thing is in parentheses. So you have to take a negative one from both of them if you're going to put it in front. This is more classically the way it should be shown, but this is perfectly acceptable. So either way here would be fine. But now you see how to do it again with a negative. You first have to figure out what numbers to use. And once you do, you can use the right formula, get the exact values from the unit circle if you chose good numbers from it. And then just be careful with your multiplying and things with the fractions. All right, I'm going to put that one aside and look at the third thing that we'll do. Now, we did verifying identities in section 5.1. We actually will do them again here, but we'll do them where one of the things you'll do at some point is use a sum or difference formula to simplify the problem. So this is still 5.2, and this is part 3, and we're going to verify an identity. So let's look at one of them, and you can see how to do it here. Verify. We're going to verify, I'll put verify this identity, or verify it is an identity. So, cosine theta plus 3 pi over 2 equals sine theta. Okay, good. So to verify it, we'll work on one side. It doesn't say here to work on both, so we'll work on only one side. This side's simpler, so we'll leave it. This one has more to do. In fact, right here we can see it's the cosine of two angles being added. We have no idea what cosine theta is, but we will know what 3 pi 2 is, so let's work with it. So the place to start on this looks like to use the sum formula for cosine to put these in. And so if I say this one's alpha and that one's beta, well, what I'm going to do is use cosine, it's the plus, so I'm going to use this cosine, but it'll be a minus in the middle. So that means it'll be the cosine of alpha, which is theta, times the cosine of beta, which is 3 pi over 2, or cosine of 3 pi over 2. We don't know that amount yet. Now we'll subtract because that's plus for this one, and then sine. Sine of theta times sine of 3 pi over 2. And if we continue working that out, we should get it equal to sine of theta. Well, let's find out. Use the unit circle, because thankfully 3 pi over 2 is on the unit circle. And we look around, 3 pi, 2 pi over 3, 3 pi over 2. Oh, 3 pi over 2 is here at 270 degrees. Right there, 0 and negative 1. So the cosine of 3 pi over 2 is 0. So we have the cosine of theta times 0 minus the sine of theta, and the sine at 3 pi over 2 is negative 1. I guess because we're trying to verify, we should put a question mark on these to see, is it really true? Is it really true? Is it really true? Well, anything type 0 is 0. And then minus times a minus makes a plus. Well, guess what? Is it really true? Yeah, we can pretty much tell now that the sine of theta is equal to the sine of theta, and we just proved it. Yay! We verified it, and we did it by taking this and putting it into the formula, and we didn't have to know what cosine of theta was. We're trying to find something with theta, so we're perfectly fine leaving it as theta. The other one gave us enough information to change things or cancel things. In this case, a 0 and a negative 1. It worked. So there's a good use of the unit circle to verify an identity like that. Okay, and there's one more type of problem that I want to go over and show you. And this will be the fourth part that I want to focus on in 5.2. Okay, so put that aside and go to this kind of problem. Okay. So that was 3, this is part 4. So on this one, we are going to find out, or we're going to find out what this is. We want to find cosine alpha plus theta. Right? We want to find out what that is. Well, we need some information. We need to be told what alpha is and what beta is. Okay? So we don't know that yet. We're going to be given some, actually, in order to do that and do out the formula, we need to know cosine of alpha, cosine of beta, and we need sine of alpha and sine of beta. So here's the information you're given. You're going to find that when the tangent of alpha is -4/3, and alpha is in quadrant 2. And you're also told that cosine of beta is equal to 2/3, and beta is in quadrant 1. We are given one of these, cosine of that, but we don't know the other 4. We don't know the sines and we don't know the cosine of alpha. But this is enough information for you to figure out what the cosine of alpha, or what the sine and cosine of alpha are. And this is enough information for you to figure out what the sine of beta is. So we have enough information here to do that. Remember, the formula we'll use, because that's plus, is going to be cosine alpha, cosine beta minus sine alpha, sine beta. So we already know this one because it's given to us. But we need to get that, and that, and that. And this information will give it to us. So first, let's start with alpha. There's a couple of things to know looking at this. You see tangent of alpha is negative, and we see that alpha is in quadrant 2. In quadrant 2, cosine's negative, sine is positive, and tangent's negative. So that tells us that when we figure out the numbers for it, the cosine will be negative and the sine will be positive. So let's remember something else about tangent. Tangent, now we know that that's equal to -4/3, but for the tangent, that's actually the y value over the x value. Because we're in quadrant 2, the x value is negative. So I can put a negative with this. That means that the y is equal to 4 and the x is equal to -3. And the reason we want that is because the sine of alpha is going to be equal to the y over the radius. We've learned that before, and now we're going to use it, which means it's 4 over something. We don't know what. We just know it's r right now. We have to figure out that r. And the cosine of alpha is going to be x over r, which will be -3 over r, and we just don't know the r yet. So here's how you find the r. On the unit circle, if we know that the x is -3, 2, 3, and then 4 for the y, we can go to that point, and we have a triangle here, and we've gone 3 this way, we've gone 4 up that way, so we have a right triangle. And because it's a right triangle, we can do r squared. Oh, this is going to the -3, so we'll do it. Distances, though, can't be negative, so it's really a positive. But to find the r then, and since the r is a distance, it'll always be a positive, that will be the x squared plus the y squared, or a squared plus b squared. So it'll be 3 squared plus 4 squared. R squared is equal to 25. Take the square root, and r is equal to plus or minus 5. But because it's a distance, we can only use the positive. We can only use 5. So, only positive. So that means the r is 5. So now we know that this is equal to 4 over 5, and this is equal to -3 over 5. And we now have the sine of theta, we'll be putting, or alpha rather, we'll be putting 4 over 5 in there. And we know that the cosine of alpha is -3 over 5, so we'll be putting it in there. And we already have the 2 over 3 here from the cosine of beta. So what's left is we have to find sine beta. Now, let's work with beta. So for sine beta, well, we already know that the cosine of beta is 2 over 3. We know that that's the x, and we know that that's the r. And, oh, we're in quadrant 1, and everything's positive in quadrant 1, so we know that the sine will be positive. So if I know r squared is equal to x squared plus y squared, I already have the r. So if I square that, I get 9, and I square the 2, I get 4. Whoops, I shouldn't have written it since I was already squaring. And then when I subtract 4 from both sides, I get 9 is equal to y squared. Take the square root, so y is equal to plus or minus square root of 5, but we can't use the negative. So that means it'll be a positive square root of 5. So the sine of beta is equal to y over r. We know that the r is 3 because of that. And by doing this, we get the square root of 5 for the y. Oh, there we are. We could have done this same thing too, but there's no need to when you have enough information to go right to this. You even have enough information up here that we could have skipped this and we could have just done, what was it, where were we? Oh, we had this one. We could have just done 3 squared plus 4 squared and gotten it. So it wouldn't have been a problem with skipping that little thing as well. But it's sort of nice to see it in my opinion. So here we have enough information now to do all of these things. So the formula was the cosine alpha, cosine beta, minus sine alpha, sine beta. We now know that the cosine of alpha is negative 3 over 5. We know the cosine beta is 2 over 3. We know that sine of theta is 4 over 5, and sine of beta is square root of 5 over 3. Okay, what's that allow us to do? Well, geez, just work with the numbers. So here I can cancel these out. 3's can cancel, and I get negative 2 over 5. And here I get, oh, nothing cancels, but I'll multiply. 4 root 5, and 5 times 3 is 15. Oh, well, this was a place where I should have actually not changed that yet, or change it back now so I can get a 15 and add these together. So by doing that, I'll go back to negative 6 over 15 minus 4 root 5 over 15. So that means that the cosine of alpha plus beta is equal to, and not approximate because this is an exact answer, is equal to negative 6 minus 4 root 5 over 15, or negative 6 plus 4 root 5 over 15. It's an or, so you could give this answer, or you could give this answer, just when I took the negative out of the top, I had to take it from both terms. So both are perfectly acceptable. And that's how you do the cosine of alpha plus beta. So let's go back up and quickly review what I did here. This was the given information. I used the information on alpha to get sine and cosine, mainly by using the Pythagorean theorem, and remembering y over x and y over r and x over r. And then I did the same thing with beta in order to get sine of beta. Simply plug the numbers into the right formula and do the math with it. And that's how you do it when you're trying simply to come up with what the exact value is. And I could have written, actually, yes, it should always be exact value unless you're told different here. So when you're given information like that, that's how you do that problem. And that concludes section 5.2.